Hello again out there in remote learning land. Hope you enjoyed your day away from the routine. Anyway, we're going to continue with mapping. I hope you worked hard on the Do Now questions 4042 there. I was going through a lot of the labs that were submitted on the GC, and a lot of you guys need to fix them up and resubmit them, or they're going in as no credit. So make sure you get on that. The end of the quarter is going to be here before you know it. All right. Two beautiful, one beautiful picture up front. That's called Meteor Crater out in Arizona. Story goes that there was a pair of brothers that bought the land because they wanted to mine the material from the meteor, but they spent all their money on this mining equipment and buying the land, and they drilled and found next to nothing and went bankrupt. The land ended up going back to the state or the Park Service, whatever it was. But what happened was when a meteor hits, it hits so hard that a lot of that material gets vaporized and ejects out of the crater, and you're never ever going to find much in the center. We know that now. They didn't know that then. So anyway, interesting story. And that, of course, is a depression in the land, and we're going to show you how to map those out. And this obviously, if you look closely at your screen there, you'll see Beth David Cemetery and Elmont Memorial High School. This is a topographic map of where you are right now. All right, so let's get rolling on tips to interpreting contour maps. Now, if we were in the classroom, we have this fun activity where we connect the students with strings of different elevations and make a human contour map. Hopefully we can get back and do that fun thing toward the end of the year. We'll see. All right, rules to understanding the maps. Well, first off, how are they drawn? They can never cross, right? If you're drawing the lines and they cross, you did something wrong, erase them, you got to do it again. They might touch, they usually don't, but if they do, you're looking at a sheer cliff, a steep cliff. It'll look like that. And that's a place on the land where it's a straight drop down. Okay? When you see them like this, running off the map, it usually means that they're connecting some other place, right? But that place is off the map because these lines can't just vanish. They can't just stop. They end up ultimately connecting back to themselves. Okay? Make sure you get your notes in there. How do we tell if it's a steep or a flat area? It's only going to be on a flat piece of paper. How can you tell? Well, from the side, it's easy, right? That's called a profile view, and you could tell where it's steeper right there. But on the map, it's just these circles. So where the lines are closer together, it's going to be steeper. Okay? If they're widely spaced, it's going to be less steep, right? More gentle. If they're closely spaced, it'll be much steeper. So which one of these is the steeper side? Well, if you said Y, you're 100% correct, right? They're closer together. X is a gentle slope, Y is a steep slope. All right, if you want to go sleigh riding in the wintertime, you want to go down the steep side so you can get lots of speed, have a lot of fun. The gentle side, well, you're not going to go very fast. Okay? How do we determine interval? Well, a lot of times the interval is on the bottom corner of the map, but not always. So you got to be able to figure out what it is if they don't give it to you. Well, take a look here. There are usually some thicker lines on the map, separated by thinner ones. The thicker ones are usually labeled. So this says 700, this says 800. And you got to say to yourself, all right, well, how many lines are in between? So you got to go 1, 2, 3, 4, 5, right? You got 5 lines in between 700 and 800. So you would subtract 800 minus 700 is 100 divided by that 5, and of course you would get 20. Okay? The interval is the difference in elevation, right? The change in elevation from one contour line to the next. All right? Labeling the lines is often very helpful, especially if you're trying to interpret the map. So draw them in there, and there you have it, right? Skipping by 20s. Okay? That is a 20 interval. All right. Everywhere on a contour line is the same elevation. So if you're on this line, no matter where you are, you're at 720. All right, that's what your next note is talking about. A single contour line represents one elevation along its entire length. And that's why they can't cross, because then you have two different values on the same line. It doesn't make any sense. All right? All right. Here's the whole hill-hole scenario. Now, looking at this picture, you could probably say, oh, yeah, I could tell that's a hill. All right, but remember, you're going to be looking at a flat map. It's a little trickier. Well, hills look like this on a map. They have these closed circles like so. All right, they don't have to be labeled, but even if they weren't labeled, you would know that that's going uphill because of the way the lines are drawn. All right? On a black and white map, it would look like that. Okay? But if it was a hole, it would look like this. The lines would have these little teeth marks on them. They call them Hatcher lines. And even if the numbers weren't there, you would know you're going down into a hole. All right? Get rid of the picture, show you what it looks like. That's what it would look like on a regular map. So you would say, oh my goodness, how do I know what's what? Well, clearly you could see that's got to be the hole or crater because it's got those little Hatcher lines on it. All right. This one here, how do you determine the highest possible elevation of X on the hill? Well, let's say we're talking about this spot here. Here's 40, 50, 60. How much is X worth? Well, X isn't on a line, so it can't be 60. But it's in between the line. And if there were another line, it would skip by tens. It would be 70. Well, X can't be a 70 because there is no 70, but it could be one less. So what you do is you find the highest number, add the interval, and then subtract 1. So in this case, the interval's 10. 60 plus 10 is 70, minus 1 gives you 69. And the highest X could be would be 69, right? You go to the next possible contour, and then you minus 1. Similar thinking for the lowest. How do you find the lowest possible elevation of Y? Well, now you just kind of got to work a little bit other way. So 60, 50, 40. If there were another, it would be 30. But there isn't, so you got to go 1 up from that, 31. Okay? And that's why it says next possible contour line plus 1. Okay? Here's a gorgeous panorama shot I took of that Meteor Crater a few years back. Stitched together a bunch of pictures, and you really get the feel of how big it is. Those little black spots down there, those were like seriously huge machinery, but because you're so high up and far away, they look like these little specks. After the brothers went bankrupt, a lot of the machinery stayed in the bottom of the crater because nobody wanted to carry it out. Okay? All right. So now, 1 or 2 more rules for you here. If you go from a Hatcher line to a normal line, you got to repeat your numbers, right? Same thing in this scenario. Normal to Hatcher, you got to repeat your elevation. Okay? So jot down that note in there. How do we label contour lines going this way? Well, watch closely. If you go from a normal to a Hatcher, right, that means that you're going to be going down into a hole, so it repeats 50. But if there are no Hatcher lines, well, then you're going uphill. So it's going to repeat the higher number there. I know that seems kind of weird, but if you're walking along and you go into a crater, you're going to be going down. So it's going to repeat and then go down. Over here, you're still going uphill, so the next line is going to be higher, right? There's no Hatcher lines indicating a hole or a crater. Okay? So jot that in there. When you have a circled Hatcher line between 2 major contour lines, it'll take the lower elevation. And, of course, this one for there. I think I left those in your notes. You don't have to copy the whole thing, but please make sure that makes sense to you. Okay. And you're going to crank on this map, and of course, when we get back to the meet, we will pass it around the room, see if you guys figured out these questions. It's looking for the highest possible elevation of X, a possible elevation of Y, and how do you know which way is up or down on this map? So please crank on that. And I threw one more map at you here with similar questions, right? Lowest possible elevation of A, and the range of elevation for B. So please work hard on those over the next few minutes. We'll go through those in the meet in just a minute. And of course, there's some summary questions I'd like you to answer as well. All right. So again, take your time on that, do your best, and we will meet back in the meet momentarily.